Okay. We have number 5 part B, our previous class, number 5 part C. Okay. So an excess of concentrated hydrochloric acid is added to the dark blue solution of this complex. A new complex Z. The color of the solution changes. Okay.
सर आपकी स्क्रीन नहीं
Right. Z. Yes. Okay. Just let me share my screen. Sorry. Is it shared now? Yes, is my screen is shared now?
Yes, sir.
Okay. So let me read the question again. They are saying that we are using concentrated hydrochloric acid and is added to the dark blue solution of this complex. A new complex Z is formed and the color of the solution changes. Okay, they don't tell us the color, but we have studied these color and they are mentioned in notes as well. Okay. 1 minute, please. Write an equation for the formation of Z from solution of this complex. Include the formula and charge of Z. Okay. So let me recall you that when we add hydrochloric acid concentrated hydrochloric acid, the chlorine would substitute all the ammonia and water molecules, and we have a coordination number 4, the new complex having a coordination number 4. So it would be CuCl4 with a 2 negative charge, and along with that we would write 2 moles of water and 4 moles of ammonia or ammonium. Is this understandable? Yes.
सिर्फ स्क्रीन नहीं
Okay.
नजर आ
Give me a
रही
minute, please. स्क्रीन मेरी शेयर आई हैव शेयर्ड द स्क्रीन जी बाकी सबको भी नहीं नजर आ रही
सर पहले नहीं आ रही थी अब आ रही है
ओके Okay. Okay. So is this equation is understandable to everyone?
सर एक सवाल है बस, जो सर जो HCl है उसके जो Cl है वो 4 लग रहे हैं जो सब्स्टिट्यूशन हो रही है, तो ये HCl को हम बैलेंस
Yes.
नहीं करेंगे इक्वेशन में?
Yes, we would balance it. Thank you. So there are 4 HCl, and if we balance this over here, so there must be 4 hydrogen ions, and for that I can write over here 4 ammonium ions. And there is another way of writing this equation. Instead 4 HCl, you can just write 4 chloride ions. If you would write 4 chloride ions, so here there would be 4 ammonia molecules only. There is no need to write ammonium then. Is this clear?
यस सर.
Okay. Name the type of reaction when Z forms from CuNH3 4H2O2. So what is occurring over here? Just the ligand substituted or ligand replaced substitution reaction or ligand exchange reaction. Now state the geometry of Z. So here it have a chloride, and if you recall, as I have told you that the chloride is the whenever the chloride is bonded and the coordination number is 4, the shape or the geometry is actually square planar. Okay. State the color of the solution C. So the color is yellow when uh, the complex have a copper bonded to a chlorine ligands, then the color would be yellow. Next part. Explain why the color of the
Sir?
solution. Yes.
Sir, Z की geometry tetrahedral नहीं होगी?
Yes. Sorry, I don't know why I forget. Yes, with chlorine, it's a tetrahedral and it doesn't show, cis trans or optical isomerism. It's tetrahedral. Okay. Here the color of this solution is dark blue and is different from the color of a solution of Z. Okay, and Z is yellow color. You should refer to the energies of the orbitals involved in your answer. Okay, why the color is different? So the color is different is due to, if you recall, as the orbitals split. So if in this case, this is the energy gap, then when it forms yellow, the energy gap could be actually lower or smaller or greater than that one. So we can just write that this delta E is different for both of the complexes. Is this clear to everyone? Yes. Is it clear?
Yes, sir. क्वेश्चन है।
Okay, now question number 6. An excess of aqueous ammonia, exact fine. The color changes from, okay, of this to this. Okay, so the color of this cobalt is actually pink. And when the ammonia join, so we would write pink to brown. Is this clear? Now, write an expression for the stability constant K step of this complex. And here we have an equation for this one. So, and if you recall, whenever we write the K stability equation expression, in that K stability expression, we don't include water. So as a product, we would have Cu NH3 6, 2 positive. And we put another bracket for the molar concentration divided by CO H2O6, 2 positive, times concentration of ammonia raised to the power 6. Is this clear to everyone? Okay. The numerical value of K step of cobalt hexaamine is 7.7 exponent 4. Okay. What deduction about the properties of this and this can be made from this K step value? Okay. So if this value is this much, it means that in this reaction mixture, the amount of this or the concentration of this complex would be higher and the amount or the concentration of this complex lower. Is this understandable?
Yes, sir.
Yes. Is this clear to everyone? Okay. So if the complex in the numerator is having a higher amount, so it means we can say that it is more stable, and this would is less stable because it turns into the other complex. So we would write that CONH3 6 2 positive is more stable than COH2O6 2 positive. Is this clear? Now, next part, oxygen can oxidize this to this. Okay, if you look, ammonia is a neutral molecule. So it means here the cobalt have a 2 positive oxidation number and here it have a 3 positive oxidation number. So it oxidizes under standard conditions in alkaline solution. Okay, use this information, and here we have an equation and the data booklet to calculate the E naught cell value for this oxidation of cobalt ammonia 6 two positive ions. Okay. So here in this case, just give me a minute, please. We have a 1/2 equation provided over here, which is actually showing, if you look at this equation, here we have a 3 positive charge and here we have a 2 positive charge, right? So as they said that oxygen can oxidize this in alkaline condition, so it means this reaction would occur in this way, because in this way it is going to lose an electron and oxidize to 3 positive ion, and we have a oxygen and hydroxide in a reaction in the other half equation, which is going to be undergo reduction. If it's undergo reduction, then in its E naught, sorry, would must be greater than this E naught value. Is this point is understandable to everyone? Yes, is this point is understandable to everyone?
Yes, sir.
Because we know that the one having a greater E naught value would undergo reduction, and the with a smaller E naught value would undergo oxidation. So we have to choose the half equation containing the hydroxide ion as it's an alkaline, and along with the oxygen. And is there, and if it oxidizes cobalt, so it means it itself undergo reduction, and if itself undergo reduction, then its E naught value would must be greater than this value. Okay, now let's have a look at data booklet first. So okay, here we have oxygen, but it's an acidic condition, so we cannot use this one. We exclude this one. Okay. See here, oxygen and hydroxide, so it can be the equation that we can use here. Oxygen and hydrogen ions. So this equation also cannot be used. Here we have oxygen and hydroxide ion. So we might use this. So its value is 0.10, and as we have decided that it must be the smaller one, so on the basis of that, as this one have a minus value, so I would cut it this one down. So I'm left with this one, and it have a 0.40 volt. So it means this can be the equation that I can use. So if I write this equation here, O2 plus 2H2O plus 4 electrons, 4 hydroxide ions, and positive 0.40 volt. Okay. So what we have to do, we have to calculate the E naught cell. Okay, that's fine. So formula for finding the E naught cell would be E value of a half cell where the oxidation is taking place minus E of a half cell where the oxidation is taking place. So here the reduction is taking place, here the oxidation is taking place. So 0.40 minus 0.30 volt. So positive 0.30 volt. Is this understandable to everyone? Equation for this oxidation of CONH3 twice. So here as the oxidation is taking place, so it means I will flip this equation. So if I would flip this equation, so it would be so we flip this equation. So here we get, so I have to multiply this equation with the 4 because there are 4 electrons. So now the equation would be CONH3 place the reactants on the left side of the arrow, and then the product would be here are left with the hydroxide ions. Yes, is this equation is clear to everyone? Yes, is this clear?
Yes, sir.
Okay. Now predict by selecting the suitable solution in the absence of ammonia. Explain your answer. Whether the oxygen can oxidize cobalt to positive. Okay. So let's have a look. First have a look at the equation for a cobalt, specifically the oxidation of cobalt. Okay. oxygen and let me write the equation over here. So this was right. Then we go for the copper. Where cardboard to vines turning into sun. So two positives 0.2